It's been the ruin of many a poor boy, but God, I know I'm one. I know, don't quit my day job, and I'm not planning on it, believe me. Okay, gentlemen, here's what we got. See my logo on the front? Yep, this thing's been here before. Guess what? That happens when you've been in business for like 10 years. This is not a comeback. This gentleman here had a kink in his coax that eventually worked itself into being the situation of a break in the coax. And he didn't catch it until it shorted out, and it caused some things to go boom. So he sent this back in September of last year. I got so much stuff last year. Man, why'd they put the packing label right on the case? Excuse me, I shall return. Reading the note here. AM band will do 3,000 watts. On sideband, it'll do 2,500. Okay, that's radio drive and has nothing to do with the amps operation. I hook up my striker and blue when you turn, and blue. And when you turn on the amp on, there's a ton of noise, call me. Let me know what you find out. Okay. They put the packing label. This is like a UPS packing envelope. And how am I going to get this to release? And it is like perma-stuck to the cabinet here. Now, when I just called and I talked to him on the phone, he told me a different story other than what's on the note. He said he had a failure in his coax, and that's what caused the thing to pop. And he goes, then he thinks the preamp is permanently on. Oh, that's interesting. I didn't see any of that over here, so let's maybe I'll heat this up. Give me a minute. 40 plus minutes later. I actually remember doing this amp now. This is two 2290s driving a matched set of 8 Toshibas. Legit. So this thing's got like what, a 2800 watt power supply in it? And I was kind of chuckling because I was sitting here, I'm thinking about this note. On AM band, we'll do 3,000 watts. On sideband, we'll only do 2,500. So I called him and I said, man, hey, what do you realistically think an 8 transistor amplifier will put out? And he goes, I don't know. I said, most of us, if we can get 2,000 watts out of it stably, we call it a day. And the fact that you're seeing 3,000 out of it meant this thing was running really good. And I said, then your next sentence here is like, I hook up my striker. And I said, dude, you're not running a striker into this thing, are you? He goes, well, yeah. I'm like, what? No. And he goes on to explain to me that this is how he had to run it to keep it so it would stay under control. Variable all the way down. Well, if we come in here and we look, this resistor here is completely disintegrated. Because with the variable all the way down, you're taking your entire striker radio and you're dumping it to ground through that 2-watt resistor. So I think what happened here is some operator error. It is what it is. And he goes in between that and the coax issue that he had going on. That's what he just told me on the phone. He thinks he knew what's up. So I immediately think, okay, let's go in here, and I pull the lid open. I'm like, oh, Toshibas. Toshibas. Good stuff. And I thought, oh, this is going to be expensive, right? Because I'm thinking he's going to have 1 million blown transistors in here. I don't see any burnt 10 ohm smoke. Variable feels okay. Smooth. So let's grab the bench 2950 and let's hook it up. We're going to hit this with the FLIR. So we'll just pop it a couple times and see what parts are heating up and what aren't. And see how this works on the watt meter. This thing's plugged in. It's in the on position, and I can hear one of these power supplies is making some funky fucking noises. Hopefully you can hear that popping noise. Let's turn the power supply off. Okay. So now let's go up here. Turn on the 2950. I hear the noise that it's making. So that's the amp on. Amp off. Here's preamp. Preamp off. So the preamp isn't stuck on. You got one of these power supplies that's starting to fail. There's something wrong internally on one of these power supplies. There's gonna be a little bit of work to figure that out. Okay, so I can flip and hear it over here now. It's getting worse. Wow, really? Oh, I can see it on my shop radio. That's interesting. Okay, so let's just quickly kind of go in here and touch some shit. Test some stuff here real fast. There is 0 AC line noise with a nice rock solid 15.9. Okay. I don't see anything here that's going to give me pause to just not go ahead and hit this with a quick couple watts. So shut this off for a second. Turn our variable all the way open. Let's take our 5-watt slug. This 1,000-watt slug, by the way, in peak, 1,000 in average, 5-watt slug in reverse. Now we got it forward. So we'll put 1-watt carrier in this. 2 driving 8, 1-watt carrier, variable all the way open, 15, 16 volt. We should see about a 200-ish watt carrier come out of this if everything is correct. So amp on, variable all the way open. Yeah, about 200 watts. Put tunes really high though. Hello. That makes sense because the attenuators burn up now. Let's go to 2x. Hello. Okay. We're seeing 1900 and some change. I bet you anything has to do with the power supply that's failing, but the voltage is falling on its ass. Okay. Let's make this so everybody can see. That's 2x, by the way, so we're seeing 18, 1900 watts out of this thing. Variable all the way open, hitting it with 20 watts drive. Hello. Okay, so we got a power supply that's gone bad. That's what he's hearing. And that's what we see going on. Check all the pills, make sure we got heat. All the bias resistors are on. The transistors are up. Output combiner's ice cold. Power supply issues. Power supply issues. Power supply issues. Okay, so I gone ahead and I stripped this down. Let's see if we can identify which one of these it is. And I'm pretty sure it's this back one here, so. Let's see if you guys can hear this. Pretty sure it's this back one that's got a problem. So let's go ahead and I want to disconnect the 12 volt pole. And what I mean by that is I want to go down in here and I'm going to disconnect the 12 volt lead that's off of this and see if we still get LED indicator light. Because there is something wrong here, for sure. Okay, so the 12 volt lead is disconnected and it's still arcing. So go ahead and we'll unplug this real fast. We'll come down here, back that screw out, and cut this zip tie here. And we'll lift this lead, which is our hot switched 110 volt. Sound gone. Okay. Losing that one 30 amp module is the difference between this thing working properly and not working properly. So now let's run ourselves another little test. See if the noise issue. Off. We know this module is bad, but where's all the noise coming from? The plot thickens. Check this out, y'all. So when I disconnected the 110 volt primary lead to this next power supply, because I was just going to work down the chain until I found what was causing the noise, the amp is on. Okay, amp off, amp on. This module has gone bad as well. So next step, take this module out, go over on the shelf. Hopefully I got 2 more modules laying around here that I can modify and stick in here, back up and running. So he'd lost 60 amps of his power supply, and I honestly think that's from him driving it so hard. I mean, let's face it, a 2x8 that does 3,000 plus watts. Just saying. Okay, on we go. It's 10 hours later, and I've spent, I mean, in your guys' world, it's just been a couple minutes, right? I just got off the phone with this cat that, man, he's lucky to be here. Working with a power supply and a sweep tube box that's separate, blah, 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 and about killed himself today. I said, man, you got to respect that high voltage. Okay, so here's where we're at. I replaced these 2 modules, and the noise didn't go away. Check it out. I replaced these 2 modules. Noise didn't go away. I thought, okay, maybe I still have a faulty module. So this is the original module I put in, which I thought would have fixed the problem. Check it out. Okay. What made all that noise in the radio is me turning on the amplifier, bringing the power supply online. So now check this out. Let's turn this back up and check this out. Reach down here, turn the power supply on. A lot less noise, a lot less signal in the radio. But look at the voltage. Okay. $18 volts. Now what causes that to change is that there's less load. So the way that the voltage that all these power supplies have been overclocked. And this is the way xforce did it. I don't like to do this. What they do is they go inside, they remove one voltage reference resistor that goes to the variable potentiometer, then they put a diode to keep any voltage from flowing in reverse back to the board. In place of that one resistor, they jump her over to the next trace, and then they run a wire out. That's what these wires are. Then they tie them all together, and then they take one bank of resistors and tie it to ground and give one common voltage reference. Well, by doing that, bypassing that variable, it allows them to take it past the 14.5 volts that the power supplies are designed to put out, and it allows us to push the voltage up a little bit higher. Well, if we take one of these out of line, just one, now we're changing the overall load for all of the different supplies. But I noticed if I take and I put a second diode in line here, we get the same amount of voltage, but the noise goes away. And I went, wait a minute. It made me think. So this is what I want to do, is I want to check what the voltages are off each one of these supplies, because I personally believe that there's still a supply in here that's got some kind of problem. And it's taking some AC noise and it's dropping it back onto the board. The reason I think this is still a case is because even if I have this other power supply in line, which we know is good, and this other power supply that we know is good, when we go to modulate the amplifier, the voltage over here drops to 10 volts. So that means that there's another module in here that's having some kind of problem. And it's throwing off our control voltage, I feel. This is just a hypothesis. So now we have to test each one of these voltages. Now, the easiest way to do this, is to meter each one of the voltages. Well, right now they're all summed together over here on our distribution board. Well, I can undo all the supplies and let them hang out and have a rat's nest, or I can simply lift each wire. Now, the way this is laid out is this power supply is the farthest away. That means that this power lead over here on this front side of the distribution board over here is going to be its wire. All of these wires are the same length. This rule only works if the ground wires are also staggered in the same distances. What xforce has done is they've taken the power supply and they took them straight down to the board. So we're going to just kind of skirting a rule by saying the wire that goes to here goes to this power supply, and the wire that goes down here goes to this power supply. So technically they're all the same length. In theory, you'd want to reverse the distance also with the grounds, but we're going to go with just this for right now. So let me disconnect this from the fan lead. We're going to throw this up out of the way for the moment. Come on, grab a hold. Give me some bite action here. Okay. So now I'm going to go in here and I'm going to lift this wire. I'm going to hook the voltmeter up to it, and that's going to tell me what this power supply is putting out for voltage. So now all of our power supplies have the same load for the reference attached to them. I want to see what this power supply is putting out for voltage, this one, this one, this one, this one, and this one. And I'm going to write it on top of the power supplies as we go. The reason this test is necessary is because I remember very clearly when I had this amp in here for the repill and the repair initially, a long time ago, I had to switch out this module. This one here. For some reason it sticks out of my mind, and this one's got a white wire that comes out of it. The rest of these are all yellow, but they're all tied into the same circuit. So Let's go measure things. So this is our positive lead that comes from this power supply. So this one, with our load attached, is 21.20 volts. This is the power lead that attaches to this brand new tested supply. Jumped up to 14 volts. So check it out. We'll cycle it one more time. Takes off, goes up, comes back down. 6.69 volts. Believe me, this is all leading someplace. Have faith. Okay. Power wire for this module. We'll call it 8.5 just for humor's sakes. Yeah. Testing this module right here. Boy. 5.33. Okay, 8.82 volt. This thing's producing so much voltage because it does got, there's something, the diode that's in here or something, there's no reference control. And the rest of these, listen, it's just my job to come along and pick the pieces up after the frickin' party, right? So we overdrove the crap out of this thing. It made a lot of good power. We overloaded the power supply. I do remember thinking, I generally remember this, when I did the amplifier repair, I think I said in that video that, in my mind, now, even today, I see this as like, if we're lucky, a 30 amp module per unit. So 30, 60, 120, right? 150, somewhere in there. 50, 60, 70, 80. So we got 180 amps worth of supply here. But then we've got just this 8-pill section pulls 200 amps. And then this section here additionally pulls another 30 amps. And I remember I pointed this out in the initial video. I know I pointed this out in the initial video. That technically there's not enough supply here to run this thing full chooch. And I remember saying it. I'd have to go back and dig this video up, but I swear that's in there. I've never cared for this. There's not enough power supply here. It technically needs one more switcher, and there's no place to put it in here. This had, I think it had PP100s in it, if I remember correctly, with no bias. And the thing was all burnt to the ground when it came in here. And that's a testament to the Toshibas. So the guy uses this on sideband all the time. He didn't understand why it burned up on sideband. Well, it didn't have any bias on it, number one. And two, the power supply isn't really technically big enough. He'd be so much better off if he would let me bypass this 2-pill driver section and just run this. But still, he's running it, probably a 10 or 15 amp deficit. I don't know if I'm going to be able to recover these switchers. To me, I don't know. I'm gonna play what they call the trimmer game. Okay, I'm gonna take this and I'm gonna trim it so that it's got an output voltage of 16 volts, and then I'm gonna provide a separate trimmer for this one and see if I can get its voltages to come to 16 volts. Same and same and same and same. And then we're gonna run all six of these modules, and we'll see how well it holds up with this load. It ain't gonna be good though, I can tell you that right now. I'm a little on the fence what I want to do here, but each one of these have been hit hard. And that one module I pulled out of the back of here was just frickin' losing its mind. It was arcing and sparking and jumping up and down and carrying on and spitting flames and fire out of its balls and stuff. I wish there was a way I could get paid to be on the phone. I've been on the phone all day, and as I'm sitting here talking to you, my phone's ringing in my ear right now. And it's 5:35 at night. I'm just getting tired. Okay, so huge progress and great success. This is the amplifier on. And that is the amplifier off. So we fixed two things. This is the amplifier off. Listen to the noise floor coming out of the radio, right? Amplifier on, just now listen to when it starts and then let it settle down. Okay. Turn the amp off. Back to our bass noise floor. So we went from about 6 or 7 S units worth of noise with the amplifier on to less than a quarter S unit of noise. Now when it initially turns on, there's a little inrush noise and so on. But this is what we did. This power supply was putting out 21.2 volts. Now it's putting out 16.3. I can trim it lower than that. This one was putting out 6.69 volts. It's now trimmed to 15.9. It seemed like just something wrong with the variable, and you fart on it and it'd go up a tenth of a volt. So it's right at 16 volts. This one was putting out 4.75 volts. Now it's putting out 16. 8.5 volts. Now it's putting out 16. And 5.33 volts. Now it's putting out 16. And this one was 8.2 volts and it's now putting out 16. Okay, so now that we have stable power coming from each module, the way we have this tapped is off this black wire. This is for the fan over here, and it comes over to our volt probe, and that's what we're looking at over here. This is a 2,000 watt scale. Now I don't know if you guys remember. You might need to rewind the video, whatnot, and go back and look. But the way it was sitting before, when it came in here, the main issue that we've been fighting with this whole time has been power supplies. You'd modulate and it would go to about 1,500 watts. That's it. This was falling flat on its face. This was dropping to less than 10 volts, like 9.8 volts. So now everything's trimmed out the same. Let's turn on our power supply, 16.42, which is totally cool. Hello, audio. We're cruising at 14.9 volts. Hello, audio. 1, 2. Hello, audio. So we're doing well over 2,000 watts. Hello, audio. We're staying above 14 now. There's 180 ohms worth of resistance here between this resistor that's in this, here, here, and here. It's not stable. Something about tying all these circuits together and then having one mass resistor, in theory, should work perfectly. I don't know. The other thing is I put a new variable knob in the front of this thing. This was all burned up. The variable potentiometer that's right here. And then this was the resistor. So the way the customer was running this is he would take his variable knob and he'd turn it all the way down. Then he was taking his striker 955 and he was running it into this resistor. So this resistor was sucking up everything that radio wasn't getting into the amp. He's driving the bejesus out of it. So now, let's have another whole conversation. That's all fixed. This knob's brand new. Underneath is brand new. I put a 5 water in its place, just in case somebody decides to be silly and try to overdrive it. That might last a little bit longer for them. Let's have another whole conversation. That was in AM. We did this test in AM. Hello, audio, 1, 2, 1, 2, 1, 2, 1, 2, hello. That's in 2,000 watts. That's 1,000 an average. We're doing almost 1,000 an average on AM. Nothing back from the bird dummy load. Hello, 1, 2. Let's go up here. Hello, audio, 1, 1, 1, 1, 1, 1. Hello. Less than a water reflex, so we know we're good there. So the input tune is repaired. Output tune, we haven't done anything with it. But now, let's go to sideband. We'll go to lower sideband. Let's turn the sideband delay on. I also fixed the LED for the lower sideband. It was pushed through and broken, so I replaced it with the same color, new LED, put it back through the cabinet. So, hello, 1, 2, 1, 2, 1, 2, 1, 2. Hello, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Hello, 1, 2, 1, 2. Hello, 1, 2, 1, 2, 1, 2. We're getting 1,900, almost 2,000 out of it on sideband. Which this makes me want to go back and review the video from the last time it was here. Please note how much farther the voltage drops. You're dropping to like 12.5, 12.4, and that's because we don't have enough supply to adequately power the transistors. We just don't. There's just not enough of it. So now he says to me that he's going to use a 2950 to run this whole thing. I'm like, that's awesome. That'll be just about right. I could overclock this a little bit further. I could take this to where it was resting at like 18 volts, and we'll get a little bit more power out of the transistors. It's not worth it. It's not worth it. Not worth it. So what I'm going to do is I'm going to go along and I'm going to put tape across the top of these to keep fingers out of, right? We hope. But I wanted to zoom in and show you the difference in resistance. These are 1 meg resistors that I used. And we'll just say that this little T here, look at how each one of these is adjusted just slightly different to achieve the same voltages. I think this power supply has been heavily abused. I think it's been overdriven and heavily abused. Noise 4 issue has fixed. I'm really happy about that. It kind of makes me wonder if these 2 modules that I pulled out of here, they even have a problem. So I'm going to come back and I'm going to check these out. Look, the moral of the story out of this whole thing is, when I switched out this module and switched this module out, and we still had the same problem, that's where you got to stop as a technician and go, wait a minute, there's something different going on here. This should have been as simple as swapping these 2 modules out, this one and this one. When I still had the noise being persistent and the voltage was jumping out of this thing at 21.8 volts, that's at the top end of what this supply can really put out for power safely. There's some electrolytics that are in it. We're getting close to the top end. I mean, let's see here. All these output filtering caps are only 25 volts. We're getting to the top end of that. I don't know what the driver IC, what its max voltage is, and I don't know what our actual control ICs and rectifying IC stuff, where that sets at value. I've never bothered to learn the values of these, I understand the basic principles on how this works. Specifically, I can't point to that leg on this chip and say this is what it does. I don't know. I've never bothered to teach myself that. There's guys out there that are the power supply whisperers, and they could probably tell me exactly what parts inside of these have been whacked that caused them so that we can't sum them all together and have one common voltage reference. I'm not that guy. I'm not the switch mode power supply whisperer. I don't go to sleep at night with one of these cuddled up next to my butthole. I just know that, okay, hey, let's go see if we can trim them all out independently and get them to match. And we've done that. And the reason the voltage is dropping so much is because we're about 30 amps, 40 amps shy of what we really need. We really need another module in here, preferably 2. I like to think of these as only 25 amp modules. That's the reason I don't use them anymore. There's guys out there that have all kind of luck with them. And there's a million power supplies based off of them. These things work well enough for what we use them for. It is what it is. It's a blue label that was abused before it got here, so the power supplies see damage then. Then it got refilled with good parts in it. The guy spent his money in the right place, and then it got a little bit overdriven again. So I pray my customer that's watching this is hearing me that you cannot put a Striker 955 or any Striker for that matter into this amplifier. This is a low drive radio or low drive baby. All right, you can't put the John Holmes cock in, or you'll stretch her out, make her scream, and her boobies are going to explode. Can't do that. Can't have that going on. I mean, we need like a Pee Wee Herman going up in this thing. But little Pee Wee Herman radios have got big audio. Just saying. Just saying. Let's check and make sure our preamp is working. Let me tear into that now. Okay, Mr. J. Preamp is fixed. Preamp is working. Okay. This is just you and me. We're not going to think about the 1,000, 2,000, maybe 3,000 views this video gets. It's just you and me talking. I use a committed 15 amp connection. I got it on a 3-way, but I put it on the plug closest to the actual cord end. Okay, that is a committed, it's actually 20 amp. I have a 20 amp committed 110 single drop for the workbench for doing these. Okay. This is going to use every bit of voltage you can give it. If you are plugging it into an outlet that looks like this over here, you are doomed for failure. There's nothing I can do to help you. Okay? I would strongly advise that you might want to think about going to 220, which is nothing more than changing this plug out here and flipping all of these setting switches on these power supplies to 220. They're all set for 110 at the moment. You literally go tink, 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 put a different power plug on it, and you're on 220. You are at the ragged limit of what this power supply can put out. The noise that you are hearing in your receiver was from one of these power supplies tripping because it had lost its reference and was just doing all kinds of crazy stuff. That issue's fixed. Do not get in here and adjust these. Leave these alone. This will not equal more power. It might for a short minute, but in the long term, you're going to regret it. Moreover, let me do this. You're going to regret it. You're going to end up popping a module, or even worse yet, blowing a pill. I have seen this now. We have dealt with this particular case and this power supply issue for a long time. This cabinet is a holdover design from when he was using iron core transformers. Okay? I just did a previous repair on this same style cabinet with the same number of transistors in it, and it was producing far more power. But of course that was with, it was set up as a 10 pill. Okay? Please listen to me when I tell you 30 watts max drive ever into this amplifier. You're going to want to run this all the way open, not all the way down. If you've got to go and turn this down, you're only going to do very small adjustments. Remember, this is only designed to get rid of about maybe 2 or 3 watts of power without burning up. This is a low drive amplifier. You cannot put a 955 into this for drive. That is too much. You're going to end up blowing up the power supply, blowing up the variable, or at worst blowing up the 220 290s. I've even shown that on video. This guy got sold it. Same thing, but it was an xforce 12 pill. Same number of supplies hooked to a 12 pill. We already know we don't have enough here, so imagine having almost another 4 transistors hooked up in this thing, running off the same number of supplies. And the guy that sold the amplifier to him sold him a 955, and it blew the 220 290s clean out of it. I repaired it, put it on video, and watch what happens. Key down, click hello audio, and blew the... Mr. J, help me help you. This thing will run okay if you just keep your, you know, your 2950 hit, or your HR 2510, like you said, hitting it. You're on the ragged edge. And I can't be more clear than that. I went through and I zip tied everything up on the inside, got it all organized again, all nice and neat and clean. I went along and I just put a little, I don't like using hot glue too often, but I wanted to support the joints of the wires on here for shipping reasons mainly, and to help support the connections, because these wires will flex forever. It's not a big deal. But these little solid metal joints, I was worried about that. So just put a little dollop of hot glue just to help support the wire in shipping. Short of putting this in a new cabinet, there's nothing else I can do for you. Your noise issue is fixed, the preamp is fixed, your power supply issue is fixed with 2 new modules. That one that was popping in the back, I'm certain there's a problem with it. I mean, we should not hear high voltage going on ever. This has been fixed to the best that we can do with it with what we currently have available to us. If it was me, I would take these switchers out and I'd replace them with like an RSP, two RSP 1500s. We'd have to trim the board, and some serious case modification would have to go on here. But for right now, all of my test equipment and just listening to it, this thing is running titties again. We got lucky you didn't pop a pill. But please, please, I'm begging you. I'm begging you, please, do not overdrive this amplifier. Be respectful of it. Well, gents, I'm trying to find the motivation. I really am. I got a lot of stuff going on. There's a lot of stuff with the business going on behind the scenes. It's kind of got me stressed out a little bit. But this too will pass. And I'm going to continue on, no doubt about it. There's a big announcement coming up on this here. It'll be coming out probably the day after tomorrow. So make sure to tune in and check that out, and then you'll understand why I'm so exhausted all the time. It's because I'm spread stupid thin right now, but that's all getting ready to come to an end. Thank God. So, on that note, bottom of my heart, I say thank you to each and every one of you guys that sit here and listen to one of these long diatribes on why this guy burned his box up, and how did this happen, and why did that happen, and here we are. Thank you. And I appreciate your support. It's the thumbs up. Please subscribe, smash the bell. That way you get notified and you can follow along. If you don't mind, I'm going to go find a dark hole to go curl up into and cry softly in a corner now. I'll see ya. Bye.